No. So, we've finished studying proportions. Somebody refresh my memory. What is a proportion? I forgot. It does two things. Madison? You got to go through the origin. And Emma? Has to be a straight line. Yellow, green. Okay, today they're going to be...
Linear.
What does that mean? Straight line, but they are not a... So what do they not do? They're not going to go through the origin, 0, 0. But they're still going to be a straight line. Lines don't have to go through the origin. If they do, they're called proportions. If they don't, they're just a straight line. They're not a proportion. Okay, so let's start off with an equation. We'll start easy. They may ask you to make a table and sketch a graph of it. So let's make a table. And I got a question. If they don't have numbers in this table, do y'all know what numbers we always use? What?
1.
1 is in there.
2.
2.
3.
Nope.
0.
Yep. 0.
-1.
Yep.
2.
Why do we always want to use those 5 numbers? There's a reason.
Because when you add, it'll make it helps more to add.
No, it doesn't have anything to do with adding.
And also because it's multiplication and 2.
Doesn't have anything to do with multiplication.
Okay.
Keep thinking though. But there is a reason.
They're easier to multiply.
Nope. They are, but that's not the reason. Didn't we say we're going to graph it? Why do we want those 5 points, Emma? No?
Because those are the numbers that are on all 4 of the square.
Okay, now we're getting closer. They're the 5 closest numbers to the middle of my graph, people. Here's 1, here's 2, here's 0, here's -1, here's -2. Are you with me? Why would I not want to plug in 100, 101, 102, 103, 104? Yeah, I ain't graphing 103, 104. You got to make your graph go to 103, 104. I ain't doing that. Are you with me? I want the 5 numbers that are right in the middle of every graph. -2, -1, 0, 1, and 2. So today, if they do not give you any numbers, those are the 5 we're going to plug in. Now, where are we going to plug them in? We're going to plug them into the equation where x is, because they're telling me x is -2. So let's plug in -2 right here. Pick up your calculator. Type in exactly as you see it. 2, parentheses, -2. Close the parentheses, +1. I'm about to show you something cool, so type it in. -3. Y'all agree?
Yeah.
I do too. So the first y turns out to be -3. Are y'all with me? Now, if you did just type it in like I told you to, 2 parentheses -2 +1, do this. Why did you clear? See, you forgot the negative.
Yeah.
Okay, don't forget the negative. What you can do is everybody hit the blue enter button and it will re-pull up what you just typed in. Now, what's the next number we're going to plug in? -1. So erase the -2. Just go cursor back. Clear the -2. Type it in again. You forgot the negative. And change it to -1 and hit enter. What's the next number? Because -1 times 2 is -2. -2 plus 1 is -1. Now here's the cool thing about linears. I can already start to see the pattern. What's it going up by? 2. What's the next number? Without typing it in.
1, 2,
Nope, it's not 2.
0.
Nope, not 0.
1.
1. Somebody said 1. Because if we're adding 2, negative 3 plus 2 is negative 1. Negative 1 plus 2 is 1. What's the next number?
3,
3. What's the next number?
5,
5. Are you with it? Due to the fact that linears go up by the same number over and over again, the slope, are you with me? Once you can kind of figure out the pattern, you don't have to keep typing it in. As long as these numbers are going up by 1, these numbers will continue to go up by 2 every time. We can keep going if we want. Okay. Now let's graph them. Negative 2 on the x, go here first and then go down to negative 3 on the y. So negative 2, negative 3 would be right there. Check, I graphed the first point. Let's go to the next point. Go to negative 1 on the x. Here's the x. Here's 0, negative 1. And then go to negative 1 on the y. Boom. There's my next point. Go to 0 on the x. That's here. Go up to 1 on the y. Boom. What does it look like we're making? Straight line. Looks like it's going to be straight to me. If your graph doesn't look straight, you screwed something up. Does that make sense? All right, let's do the next one. Go to 1 on the x. That would be here. And go up to 3 on the y. Boom. Oh, somewhere there. And then let's do the last one. Go to 2 on the x. Go up to 5. And we can connect the dots. There is the graph of y equals 2x plus 1. We use the table to figure out what points we need to put on the graph. Here's negative 2, negative 3. Here's negative 1, negative 1. 0, 1. 1, 3, 2, 5. Questions? All right. Let's do another one. Still a hard one. Or one you may think is hard. It's not that hard. Ooh, let's do some fractions. Oh, Lord. Help us. All right, and on this one, they are going to give you the numbers they want you to plug in, which is going to be nice. So sometimes they put the numbers in the table. If there's no numbers in the table, you need to put in those negative 2, negative 1, 0, 1, 2. All right, let's plug it in. 2/3 times negative 6. Here is where your calculator is going to be handy. Type it in. 2/3, parentheses, negative 6, minus 4. What'd you get, Calvin? You got negative 8? Y'all agree with negative 8? The nice thing about the calculator, people, it'll multiply 2/3 times negative 6 for you. Don't start crying because you see a fraction. It's okay.
Wait, I got 16. So.
You got 16? Let me see what you typed in. You hit negative 4. It's minus 4. So you just multiplied by negative 4. So I think I agree with Kendra. What'd you get? 8?
Negative 8.
Negative 8. Got it. All right, let's type in the next one. 2/3 times negative 3. What do we get? Negative 6. Oh, sweet. I think I can see the pattern. It goes from negative 8 to negative 6. What's the next number?
3.
Nope.
Negative 2.
Negative
4.
4. They're going up by 2, knuckleheads. 8, 6.
That'd be 2.
Negative 4. What would the next one be?
Negative 2.
Last one?
0.
There we go. If you can't pick up the pattern, just keep typing them in. All right, let's graph it. Here's my X, here's my Y. I need to go to -6 on the x. Here's -6. And go down to -8 on the y. -6, -8 is way down here. Let's go to -3. There's -3. Go down to -6. Right here. Let's go to 0 and go down to -4. 1, 2, 3. There's -4. Does it look like we're making a straight line? Yes, that's good. Let's go to 3 on the x and go down to -2 on the y. Somewhere right in there. And then let's go to 6 on the x and go to 0 on the y. Does it look like we've got a straight line going? Yep, sure does. And on the homework, they have a nice graph where you won't have slightly crooked points like mine. I don't have the grids on there. Okay, any questions so far? So how do we get this table? Somebody refresh my memory. How do we get these numbers over here? What do we have to do? Are y'all asleep? What did we just do to get these numbers? We plugged in. We plugged in these numbers for x. You are going to have to do that a lot throughout the rest of your math career. Plug in numbers into an equation for x to find out what number goes in the y column. Does that make sense? And you just plug it in right there where x is. All right. The second thing you're going to have to do today is they're going to give you a situation. What is a situation? Thank you. Who said that? Word problem. Who said that? Oh, that was you. It sounded like it was here. My hearing is off a little today. So let's start with an easy word problem. Layla has, excuse me, 2 dogs and adds 1 dog per week. Layla is a dog lover. She's already got 2. She's going to add a dog every week. So here's my question. We could make up a graph for this. But here's the question. Does the graph need to be connected? Or leave it as just dots? Now, if we connect the graph, that means that every number on the graph has a value. So let's just look at the graph for a minute. Here's x, here's y. X is weeks. Y is dogs. How many dogs does Layla start with? 2 dogs. So we're going to have our first point right here at 2 dogs. Are you with it? At 1 week, how many dogs does she have now? 3. We added 1, didn't we? Yeah. At 2 weeks, how many dogs? 4. We added 1. And we can keep adding until Layla runs out of dog food. Are you with me? She's eventually going to run out of dog food. Okay, here's the question. Do we need to connect this graph and make it what is called continuous? Put this in your notes. Continuous is connected. Or are we going to leave it discrete, which means we're only going to leave the dots? Here's how you determine which one to pick. Because each graph could be connected, or it could be left as just the dots. Is it possible for Layla to have any number between 1 week and 2 weeks?
No.
We can't figure out what 1.5 weeks is? Can we figure out 1.5 weeks? Yes. Does that give me a value in between 3 and 4 dogs?
Yeah.
can we have between 3 and 4 dogs?
No.
Why not?
Because that's one dog.
Yeah, we're not gonna cut up a dog. That'd be cruel. Are you with me? Is it possible for Layla to have between 3 and 4 dogs? No. So if you say we're not gonna connect it, it is not continuous. It needs to be discrete. So we are not gonna connect this graph. We could keep it going though, but we are not gonna connect because Layla cannot have 3.71 dogs. She's either gonna have 3 or 4. Nothing in between those numbers. Does that make sense? All right, questions on that one? Let's look at another one. Mr. Murphy's hair is 1 centimeter long. Quit laughing. Facts are facts, people.
Right here.
Oh, sorry. It's because there's not much.
Mr. Murphree.
Mr. Murphy's hair. All right. It's 1 centimeter long and grows 1 centimeter per week. Let's graph old Murphy's hair. X, Y. What is X going to be in this problem?
The weeks.
The weeks. What's Y going to be?
The hair. The line.
The length of my hair. Or centimeters, whatever you want to call it. All right, so where do we start at? 1. At the beginning, how long is my hair? So let's start at 1. Every week, how long is my hair now? 2 centimeters. So after 1 week, we go up 1. It's now 2. Let's keep going. 2 weeks. 3 centimeters. 4 weeks, or 3 weeks.
4 centimeters.
4. 4 weeks.
5 centimeters.
5. And we can keep this graph going until Mr. Murphy gets a haircut, then we'll start all over again. All right, question. Do I need to connect this graph?
Yes.
Why?
Because your hair grows a little more, and like you can have more or less than 1 centimeter.
Okay, so let's see. At 2.5 weeks, can we measure Coach Murphy's hair?
Yes.
Will it be in between 3 and 4 centimeters?
Yes.
Yes, hair can be decimals. Does that make sense? So in this graph, we need to connect it because Murphy's hair can be measured and has a length in between any of these decimals. Between 3 weeks and 4 weeks, it's going to be somewhere between 4 centimeters and 5 centimeters. It might be 4.7, 4.2, but every number in there could be the length of my hair. Does that make sense? This is continuous. Ooh. So that is how you look at a graph, kids, and tell if it's going to be continuous or if it's going to be discrete. If it's going to be discrete, there has to be a reason. Like Layla cannot have 3.7 dogs. Does that make sense? No, we're not going there. It's either a dog or it's not. A 3-legged dog is still a dog. Yes, can I get an amen?
Amen.
3-legged dogs are the best, by the way, dude. They come running out. I love them, dude. They're like, I don't care that I only got 3 legs. I'll still kick your butt. I love them. They're awesome. Like, they're the epitome of we will overcome in this life. I don't need that leg. I'm good. I'm good. I've even seen the 3-legged dog jump up into a truck. I'm like, wow, that dude is impressive. Like, all right, so when you're looking at graphs, make sure you think about it. Can we have all the numbers? If the answer is yes, connect it. Can we have all the numbers? If the answer is no, don't connect. Does that make sense?
Yes, sir.
All right. Here's the homework.